In this lesson, we will continue looking at section 40 on limits and continuity. The use of the calculator is not allowed. The focus of this lesson is on continuity. When we're trying to decide if a function is continuous at a particular value, we need to meet the following conditions. Condition number one is that it has to exist at that value. So say we're evaluating a function at 3, f of 3 needs to exist. The limit at that value also would need to exist, which means we're looking at it from both sides. They both need to come to the same value, and that would mean that the limit exists. And then part C is saying that the value that we would get for part A and the value we get for part B, they have to match. And as long as we meet all three conditions, we can say it's continuous at that particular value. So here's our first example. Now again, we're not looking at the entire graph and determining if there's any breaks in the graph or if we have any discontinuity here. We are just looking at 6. So I go to 6 on the x-axis and I'm questioning just right here if it's continuous. So part A would be, does f of 6 exist? Could I evaluate it there? Yes, and I would get -6 for that. For part B, I'm looking at the limit. And again, I have to look at the left and the right sides. As long as they're going to the same value, that means that the limit exists at that particular point. For part C, I'm going to figure out, does the value that I would get for part A and the value that I get for part B match? Since these do match, that's going to indicate that this one is going to be continuous at x equal to 6. For number 2, it's the same graph, but now I'm looking at -2. So first of all, when it says f of A exists, we're looking at f of -2 and we're thinking, like, could we evaluate it there? Well, I have 2 points that I'm looking at, and the one that's filled in is where I would evaluate that because it's actually graphed there. So that answer would be -2, but it does exist. For part B, I'm looking at the limit, and here, if I look at my two sides, they are not going to the same value. So since that part is not consistent, I'm going to say that the limit does not exist at -2. As soon as one of these conditions is not met, we can say that it's not continuous. So it's not continuous at -2. There's 2 types of continuity we'll be looking at with these. We're going to be looking at point discontinuity and jump discontinuity. This here is an example of jump discontinuity. Jump discontinuity is going to occur when we are going to jump from, if I was tracing this graph, I'd be on this piece and I'm jumping down to this piece. It also occurs, you can think about it more analytically, that if you can evaluate it, but that the limits don't meet, that's going to indicate jump discontinuity. A different graph now, we're going to assess this one when x is equal to 0. So at 0, once again, we're looking, does it exist? If I wanted to evaluate it at 0, I would get 0. It's going to be this point right here, so it does exist. Then when I'm looking at the limit, I'm looking at left side and right side. They do go to the same value, and that means that it does exist there. For part C, I'm looking at, do parts A and B match? Well, part A, my answer would be 0. For part B, the limit would be 0 as well. So since they both go to the same value, I can say that part C is met as well, and that means that this one is continuous at 0. For number 4, I'm looking at 6. Now at 6, when I go to evaluate that, I would not be able to plug 6 in because I've got that open circle right here. So I would not get an answer for that. It is undefined at 6. So it does not exist. I really don't need to go any further within this, but if I look at the limit, the left and right sides do come together, and that's going to tell me that I'm going to have a limit there, but that it's not continuous since condition A was not met. This here is going to be an example. Again, we have point discontinuity and we have jump discontinuity. Jump discontinuity is going to happen when the issue up here was the limits. The limits didn't match. Here the limits match. They both went to the same value, but that value was an open circle on our graph, and that's going to be point discontinuity. So for number 5, we're looking at, is f continuous at x equal to -4? So at -4, again, you could write out all 3 steps, or we could just kind of look at the graph here and think, well, we are going from one part of the graph and we're jumping to the other piece. So right away, I can say that this is going to be jump discontinuity. It does exist at -4. The limits do not match though. So again, that's why this one is going to be jump discontinuity. Next, we're going to look at 0. And again, at 0, I could go through all my steps, but I really just need to make sure that I don't have any open circles, and that I don't have a jump at that point. I could evaluate this, the two sides come together, and that's going to indicate that it's going to be continuous at 0. And this should say f is continuous at x equal to 0. At 2, when I look at 2, again, I could go through all the different steps. It would not meet condition A because, again, you can't evaluate that there. But because the two sides are coming together at an open circle, this is going to indicate point discontinuity at 2. Now we're going to switch to looking at these based on their piecewise functions written out algebraically. So we're looking at, is f continuous at x equal to -4? So when we're looking at -4, we want to first of all see if it's at an endpoint. If it's at an endpoint, we're going to have to look at it for both of the pieces. So first of all, I want to say, part A, does f of -4 exist? Well, yes, because it has an equal right here, I would be able to plug the -4 into this piece and I'd get +4. So condition A is met. Condition B, when I'm looking at the limit, well, I want to look at the limit on the left side. The limit on the left side, we just assessed that when I plug that in here, is going to go to 4. On the right side, though, I've got to plug that in here. So -2 times -4 is going to give me +8, and 8 minus 4 is 4. So since my limit matches for these two, I can say that the limit does exist there. Part C is that what I got for part A and what I got for part B have to match, and they do. So since all those conditions are met, we can say it's continuous at x equal to -4. For number 9, now we're looking at 2. And again, if it's at an endpoint, we're going to have to assess it for both of these pieces. The initial step is to look at, could we evaluate it? If one of these did not have an equal sign in it, I would not be able to evaluate this. But because this one has the equal sign, I can plug it into this piece and I'm going to get -8. Then when I'm looking at limits, on the left side, that would be this one. If I plug that in here, I'm going to get -8. Then on the right side, if I plug it into x minus 10, I'm also going to get -8. So that limit at -2 is going to be -8. Part C, I'm checking to make sure that parts A and part B matches, and they do. So that's going to tell me that it is continuous at x equals 2. For number 10, I'm looking at 4. Now 4 is not in an endpoint. It's within this region. So that means that I don't have to look at two different pieces. I can just assess it for this right here. Also, you want to think about the fact that our continuity, our discontinuity, or any interruptions at the graph were always happening at some type of an endpoint, some type of interruption. So this one is going to be continuous. If you wanted to check it, we would say, well, when I'm looking at does it exist, I would just plug it in here, and yes, it does exist. I would get -6. Then when I'm looking at the limit, I don't have to look at both sides. The limit is just going to be -6 on that one. And you can see that it did assess it from both sides, but again, that wasn't necessary because it's within the region. Part C, they're both going to match, and therefore it is continuous at 4. For number 11, I'm looking at -4. So again, I see -4 attached to two different pieces. For this piece right here, that's where I would be able to evaluate it. So I could go ahead and plug that in, and I would end up getting -3. It does exist, so it meets condition A. Condition B is when I'm looking at the limit. If I look at the left side, I know for that I'm going to get -3. The right side, I'd be plugging this -4 into this piece right here. And for that, I'm getting -9. So here my limits are not matching. And when they don't match, I'm going to say that the limit of f of x as x approaches -4 does not exist. So this one is going to have discontinuity. Now it's a matter of what type. Well, again, like we saw before, if our limits are the issue, that's when we're going to have jump discontinuity. For number 12, we're looking at 2. Now, both of these are going to go with this same piece. However, there is some type of an interruption at 2. So the first thing we're looking at is, could we evaluate it 2? Well, we couldn't. 2 does not exist, or f of 2 does not exist, because neither of these have an equal sign. So that is going to indicate that I have an open circle at 2. So since that first condition is not going to be met, right away, I know that this is going to have discontinuity. And again, if the limits come together, but the issue is that it's an open circle, that's an indication that it's point discontinuity. For 13, I'm looking at 5. And again, 5 comes up in 2 different places. So right away, I've got to test them in both. When I look to see if I can evaluate it at 5, as long as it has the equal sign by that, then yes, I can. So if I were to try to plug that back in to this piece, I would go ahead and get 9. But it does exist. For part B, the limit on the left, like we just talked about, is going to be 9. But the limit on the right is going to be 5 when I plug that 5 in for x here. So since those limits don't match, it will not exist. So this is, again, an indication that it's going to be jump discontinuity because the limit was the issue. They're going to 2 different values. So please complete the exit slip that's associated with this lesson, and your homework is in practice set 40.